So question 9 says the graph of f of x equals x minus 1 squared minus 2 for x is an element of negative 2 to 2 included. And that is shown below. The graph intersects the x-axis where x equals a. Find the value of a. So the value of a is just when y equals 0. So all we need to do is substitute in, or I should say f of x equals 0. So we have 0 equals x minus 1 squared minus 2. So if we expand this out, we have 0 equals, don't really need the bracket, x squared minus 2x plus 1 minus 2. So those three terms there are just the expansion of that. So we just expand. Then we can collect up terms. So we have 0 equals x squared minus 2x minus 1. So plus 1 minus 2 gives me minus 1. And then all we need to do is solve for x, and that's going to give us our a value. So probably I'm going to use the general quadratic formula. So we're going to say that a is equal to minus b plus or minus b squared minus 4ac divided by 2a. So again, this is not on your formula sheet, and you should be committing it to memory throughout the semester. So here we've got a equals 1, b equals minus 2, and c equals minus 1 from the coefficients of x squared, x, and just the single scalar out the end. So therefore a equals minus 2 plus or minus the square root of minus 2 squared. So minus 2 squared minus 4 times a times c over 2 lots of a. So that means we've got 2 plus or minus the square root of 4 plus 4 is, 8, but I'll just put it in as 4 plus 4 at the moment, divided by 2, which equals 2 plus or minus the square root of 8 on 2. And now I'm going to turn the 8 into 2 root 2. So just to clarify that up here, the square root of 8 equals the square root of 4 times the square root of 2 equals 2 root 2. So that's where we've got that from. And then cancelling off the 2, we have that a equals 1 plus or minus root 2. And we've just got to make the choice of which case a is. So over here, hopefully you can see that a is less than 0. So a less than 0 implies a, put in a equals 1 minus root 2. And that's the answer to this question. So the same graph is shown of f of x, and where we've previously found a to equal 1 minus root 2. And it says, on the axis above, sketch the graph of g of x, which is equal to f of x, taking the absolute value, plus 1. So in order of what we do, we first take the absolute value, and then we translate 1 unit up. So the absolute value means, if I just do that in green, the absolute value of this would just look like all of that, and then we reflect this to be all above the x-axis. So hopefully you're familiar with what the modulus function does. And then the plus 1 part just moves every point on this curve up 1. So we're going to go through that point, through that point. We're going to go now through that point. that sharp point will become here, and that point will be up there. So I'm going to remove the green graph now, and all we've got to do is join up these blue dots. So we go something like that, and then back up here. So a little bit dodgy on the computer screen, but hopefully you get the gist of what the graph of g of x looks like. So g of x is in blue, so we've graphed the absolute value of f of x, oops, that's a straight line, plus 1. And now it also says label the endpoints with their coordinates. So this endpoint's included, and it's now 2, 2, and this one here is now -2, 8. And you could find that a couple of ways. So you could just, probably the easiest way that I've done is everything's just been moved up from the green graph, and we knew the locations of all their points. Another way, if you wanted to be really super careful about it, we could say that g of x, oops, I'll do that in blue. So g of x is equal to the absolute value of x minus 1 squared minus 2 plus 1. So then I can do g of -2, which is equal to square root of -2 minus 1 squared minus 2 plus 1, which is going to give me the absolute value of, so -3 in there squared, which is going to give me 9 minus 2 plus 1. So 9 minus 2 is 7 plus 1 equals 8, which gives me the point -2, 8. And then the second point I need to investigate is g of 2, which is going to be 2 minus 1 squared minus 2 plus 1. So just subbing it into g of x, which is going to give me the absolute value of, so 1 squared is just 1 minus 2 plus 1. So the absolute value of -1 is 1 plus 1 equals 2, which gives me the coordinate 2, 2. And just to be really careful, you've got to make sure they are coloured in dots at the end point, because they are included in our domain because of these square brackets up here. Square brackets for both of those. So question 9c, we're dealing with the same f of x, and the following sequence of transformations is applied to the graph of the function g. So starting at g, we're going to do a translation of 1 unit in the negative direction of the x-axis, a translation of 1 unit in the negative direction of the y-axis, and a dilation from the x-axis by a factor of 1/3. We want to find the rule of the image of g after this sequence has been applied. So let's see what that means. So originally we had that g of x, if I just put that first, so g of x originally just equaled the absolute value of f of x plus 1. So if I call this number 1, this number 2, and that one number 3, let's see what that's going to do to g of x. So the first one, g of 1, is equal to, so a translation of 1 unit in the negative direction of the x-axis is going to be the same as f of x plus 1 inside the function equation there. That's going to move it 1 unit in the negative or left direction. The second thing we need to do is translate in the negative y direction. So we're going to take our pre-existing f of x plus 1 in the modulus function, then we're going to take 1 away from that. So we're going to have plus 1 take 1, which is going to leave 0 there. Then the third thing we're going to do to this is we're going to dilate from the x-axis by a factor of 1/3. So to do that, we're just going to introduce 1/3 out the front of the x plus 1, And again, that turned into plus 0, so we just leave that off completely. So now we know what the three transformations do to the function equation. We've just got to put that in our actual equation. So now g of x, which I guess we could just call g star our new one, just to know that it's not the same as the old one, is going to be equal to a third outside of x squared minus 2, because so I might just need to explain what that is. So wherever we've got x, we put x plus 1, and there was already a minus 1 there. So these two cancel each other out, just leaving x squared minus 2 to the absolute value, which is just equal to a third x squared minus 2. And that's the answer to the image of G after our sequence of transformations is performed. So now we've performed these transformations, and we said that our G star, our new G, was just a third of x squared minus 2. And it now says find the domain of the image. So we want to know what our domain is. So the domain has only been affected by the first translation, where we translate, so this is the only one, and we said it was blue before. Number 1 was the only one that affected the translation in terms of the x-axis, which adjusts the domain. And that one said we moved it 1 unit in the negative direction of the x-axis. So our domain of G star is now going to go from -3 up to 1 instead of -2 to 2. So we just take every unit, every point, and move it along 1 unit in the negative x direction to get that new domain. The other two, hopefully we called it 2 and 3, these don't have any effect on the domain. They're only affecting the y translations and the dilation, which again isn't going to change that domain. So no effect for these, just number 1 that we've got to take into consideration.